Okay, so today we're going to do the 6th page of the review guide, and in this one we're using dimensional analysis to do mole conversions. And so instead of giving you just all of the mole conversion or all of the conversion factors, or the 3 that you have to memorize, milli, centi, or kilo, we are going to be giving you the conversion factor, the relationship between 1 mole of anything and the number of atoms that it has, which is right here. That's the 6.02 times 10 to the 23rd Avogadro's number. The other relationship that you're going to be using for some, but not all of the problems will be from your periodic table. And on your periodic table, you'll be getting the relationship between 1 mole of an element and its mass. So to start off, we're going to go with okay, so in the first one, we are given that we have 388.2 grams of iron, and we're changing it into moles. And one of the things that I had kind of given to my classes was this mole conversion chart. So I'm going to pause the video here and fill this in for you for a second. Okay, so this mole conversion chart here is just a visual representation of what type of problem or types of problems you're going to do. And the way that I usually have attacked it with my students was if you start with a mass, something in grams, right, and the problem asks you to find moles, then you are just going from mass to mole, and you don't have to worry about the particle part at all. So you don't end up using the 6.02 times 10 to the 23rd. So that's a good example of the first one, and we'll come back to look at that in a minute. So I'm going to start with my mass, which is what I was given to, which is 388.2 grams of iron. And I'm going to put it over 1. And since we're going to go from mass to moles in this problem, I know that I only am going to do a 1-step conversion. And so if I'm going to go from mass to moles, according to what I have up in my mole flow chart up on the top, I need to use the molar mass. And the molar mass is the number of grams that are equal to 1 mole of an element on the periodic table. So in this case here, I know that grams of iron can be equal to moles of iron, and that would be the conversion factor. And so if we have iron on the periodic table, and here's where iron, there it is, it's 55.85 grams. So the mass of iron is 55.85 grams of iron, and that's always equal to 1 mole of iron. So when I go to set this problem up, I need to put grams on the bottom to cancel out the unit of grams, and I'm going to put moles of iron on the top. And now, because I know my conversion factor is 1 mole is equal to 55.85 grams, I'm going to now go and do my math. So just like we were doing with the problems before, I'm going to do this one time, and then I won't continue this process. So 388.2 times 1 is 388.2, and that's going to be grams of Fe times moles of Fe, and that's going to be over the 55.85 grams of Fe. So hopefully you can see that the unit for grams of iron cancels out, and we'll be left with moles of iron. So now I'm just going to take the 388.2 divided by the 55.85, and we're going to get a value in our calculator that's something like 6.950760967 or something along those lines. Now we need to go ahead and assess significant figures. So the way that I usually do it is I look at the number that's been given to me in the problem, and that usually determines the number of significant figures that my problem will have. So in this instance here, I'm going to draw that line, and I'm going to count 1, 2, 3, 4. So I have 4 sig figs. The number of sig figs in the relationship, so this value right here is really considered to have infinite significant figures because it's a relationship. And then I guess if we were to assess this, we can count this 1, 2, 3, 4. This one would also have 4 sig figs. So my final answer has to have 4. So I'm going to draw a line or draw the arrow and count 1, 2, 3, 4. Draw a line, and that 7 absolutely rounds that 0 up. So my final answer here is going to be 6.951, and it's going to be moles of iron. I'm going to put that in a circle or a box. So when I do these types of problems, that's what I'm going to be looking for, is your assessing of the significant figures and also setting up your problem so your units cancel out. Okay, let's go on to the next problem here. In this one, I have what appears to be, I'm given the unit of atoms, which is like particles. I should put that back up here. So particles are atoms or ions. Okay, so atoms or ions can be particles. So in here I have, I'm asked to convert the 1.204 times 10 to the 24th atoms of lithium, and I'm going to put that over 1. Now, in this case, we're going from atoms to moles, right? So I'm going to go back up to my flow chart, and I'm going to see that particles or atoms is on the right-hand side going to moles. And so there's just one arrow going from particles to moles. I don't have to do mass at all. So I'm just going to use the relationship 1 mole is equal to 6.02 times 10 to the 23rd. So I know that 1 mole of lithium is going to be equal to 6.02 times 10 to the 23rd atoms of lithium, because that's the relationship. And so in this problem, we're going to go from particles to moles. Okay, so I'm just trying to set up what we're doing here. And so so my relationship is present, and now I'm going to set it up so I can convert my units, and I have atoms of lithium on the top, so I need to get rid of atoms of lithium, so I'm going to put atoms of lithium on the bottom and moles of lithium on the top. And since the relationship is 1 mole of lithium is equal to 6.02 times 10 to the 23rd atoms of lithium, now I'm just going to do my math. So I'm going to multiply straight across and then divide. So in this case, I'm going to end up with, I'm going to take the 1.204 times 10 to the 24th divided by 6.02 times 10 to the 23rd. And my calculator happens to give me an answer that's equal to exactly 2. So now I need to go and figure out the number of significant figures that I need to have. So I'm going to go back and draw my line here and say that this has got 1, 2, 3, 4. So that's 4 sig figs. This one has 1, 2, 3. So that's 3 sig figs. Even though my calculator gave me 2, I have to add enough digits to make it have 3 sig figs. So that means that this is going to be 2.00 moles of lithium. There's nothing to round. We're just going to add to make sure that it's the same. Okay. Now, next one. This one is a little bit more complicated because I see that I have grams. So I've got mass, and it's asking me to make atoms. So if I go back up to my top here, I'm going to start with mass and end up with particles, but there's no direct link. So that means that I have to go mass to moles and then moles to particles. So that means it's going to be a multiple step problem. So I'm going to go mass to moles and moles to particles. So that tells me I'm going to have a few more steps here. So I'm going to start by taking my given, which is 2.00 grams of boron, put it over 1, and I'm going to go mass to moles, moles to particles. Now, in order to go mass to moles, according to the mole flow chart that we have up on the top, we need to use the molar mass. So I need to figure that out. So I'm going to look for grams of boron equal to moles of boron. So if I locate boron in the periodic table, I see that boron has a mass of 10.81. So that tells me that in 1 mole of boron, there should be 10.81 grams of boron. Okay, so I'm gonna set that part of my problem up first. So I'm gonna put my 10.81 grams of boron in the bottom and my 1 mole boron on the top. So now I need to go from moles to particles, and when we go from moles to particles, we need to use the relationship that has 6.02 times 10 to the 23rd, also known as Avogadro's number. So just to kind of get that back into our view, I know that there are 6.02 times 10 to the 23rd atoms of boron in 1 mole of boron. So going back to my problem, I see that I have moles on top, so I'm going to put 1 mole of boron on the bottom, and I'm going to put 6.02 times 10 to the 23rd atoms of boron on the top. So now hopefully you can see here that the units, grams of boron cancel out, moles of boron cancel out, and I'm left with atoms. So now I'm going to multiply straight across. So I'm going to take 2 times 6.02 times 10 to the 23rd divided by 10.81. And this gives me a calculator value somewhere in the ballpark of 1.113783534. And my calculator says E23. Now, we don't write E23. We have to write it as times 10 to the 23rd. And now we also need to go back and assess significant figures. So if I'm going to assess significant figures here, I count 1, 2, 3. This is 3 sig figs. Down here, I'm going to count 1, 2, 3, 4. That's 4 sig figs. And up here, I'm going to count 1, 2, 3. That's 3 sig figs. So my final answer has to have 3 sig figs. So I'm going to draw 1, 2, 3. And in this case, the 3 cannot round that 1 up. So my final answer is going to simply be 1.11 times 10 to the 23rd, and the units will be atoms of boron. So something like that. All right, the last one is going to have us convert atoms to grams. So we have atoms and we're looking for grams, which is mass. So the first thing I'm going to do is go back up here and see that I need to go from particles, which are my atoms, to, I want to use a different color. So I'm going to go from particles to moles and moles to mass. So that means it's going to be a multi-step problem. So I'm going to take my relationship that says 6.02 times 10 to the 23rd atoms of aluminum is equal to 1 mole of aluminum. So I'm going to set that part of my problem up first. So I'm going to take the 6.02. Nope, I lied. I'm going to take my given, which is 1.21 times 10 to the 24th atoms of aluminum, put it over 1. And now because I'm going to go atoms to moles, I need to have atoms on the bottom. So I'm going to put atoms of aluminum on the bottom and moles of aluminum on the top. My relationship is 1 mole of aluminum is equal to 6.02 times 10 to the 23rd atoms of aluminum. Okay, so now I need to continue going down the path to grams, and we know that the relationship between is the molar mass, right? So we're looking for grams of aluminum and its relationship with moles of aluminum. So if I grab my periodic table, I'm going to see that aluminum is right there. It has a mass of 26.98 grams. So that's going to be 26.98 grams of aluminum is equal to 1 mole of aluminum. So now I'm going to set my problem up so I can cancel out moles. So I'm going to put moles of aluminum on the bottom and grams of aluminum on the top. I see that I'm going to put the 26.98 grams of aluminum on the top and 1 mole of aluminum on the bottom. Based on what I have set up here, I can see that atoms cancels out, moles cancels out. I'm going to be left with grams, which is great. 1.21 times 10 to the 24th divided by 6.02 times 10 to the 23rd times 26.98. The calculator gives me, did I do that? Yep. So the calculator gives me a value of, let's see, gives me something like 53.7807.309. Oops, I don't know what that number is. 09. Let me check my answer. Oh, I miscalculated. Hold on one second. 1.21 times 10 to the 24th divided by 6.02 times 10 to the 23rd times 26.98. Yeah, I made a mistake. I used 120 instead of 120, 1.2. I used 1.20 instead of 120. So my right answer should have been 54.222890.365. Now we have to assess significant figures. So coming in from the left, this has 1, 2, 3. So that's 3 sig figs. This guy here has 1, 2, 3, so that's 3 sig figs. And this here has 4 sig figs because 1, 2, 3, 4. And so I'm going to start drawing a line and counting for 3. 1, 2, 3. That 2 cannot round the 2 up. So my final answer is going to be 54.2 grams of aluminum. So that's page 6. So if you have any further questions about this type of problem, see your teacher and we will see what we can do to help you out. Otherwise, good luck studying for your semester exam and see you soon.